Yeah. So, so welcome you all in our this next session. Am I audible? Okay, thank you, Sridhar. So what we are now see, morning we covered the basic fundamental of image processing. What is the sphere of image processing? What type of different operations are involved in it? We had the overview, as well as then we went into the detail that what does the basic image consist of, what is the role of the pixel, what is the role of the pixel boundary. We discussed the different type of adjacency, four neighbor adjacency, eight neighbor adjacency, m neighbor adjacency. See, now we will discuss some problem because it will help us to better our insight into what is actually going on at the image level, because and also it will create the more interest in the content, because in afternoon session generally it is not that easy to remain awake, so these problems are bit mathematical in nature, so they will help us to that way also. So what I have taken, so here we have taken the some problems, we have solved problem, so that so what is starting with a problem. A photograph is given, right? Many people would be thinking, see, that we are dealing with the images from a long time, but we have never ever dealt with the pixel. So definitely see how does it come in picture, so that example will help us to get that insight. A photograph is there, which is basically W inches in there in width and H inches in height, was scanned at 1000 dpi. What is this DPI? That is basically dots per image. So what is the dots? Dots basically again represent this basically the pixel. How many pixels are there? So here's it what we are going to show you. Dots per inch actually, right? Image has a resolution of 100 pixels. So what is given that it is W inch in width. So it is given that it is 100 pixels in width and 200 pixels in height. What is the physical size of image, right? What you are, if you are seeing very carefully in this question, nowhere actually we measure the things in terms of the height, but it is indirectly given in form of the pixel. So what will be the thing? So first thing, the physical size of the image, what we are seeing that it is basically the uh, number of pixels are basically physical total number of, see what we are saying, it is in pixels per inch, right? So total physical size, for example, we say it is basically the capital P, there's a P inch, then total number of pixels will be P inch multiplied by pixels per inch, right? I repeat it again. For example, what is given here in this question? Here, if you see that the width is given and height is given in terms of the pixels, so that way, as we are saying, it is our two-dimensional image. By two-dimensional image, we are able to calculate the total number of pixels. And when we are saying that we are able to calculate total number of pixels, then it is also giving the idea that, for example, the size of the image is X. X inch. Then total number of pixel, if 1000 pixels are per inch and size of the image is X inch, then number of pixels will be X into 1000. That we have written in the same way, X into 1000, then physical size will be number of pixels upon pixel per inch. I think, is it understood? It's simple problem, but it's connecting that how does the things look like in form of the pixel? How do we correlate this concept? Scan resolution, again, it is a what we call this figure, this pixels per inch, it is basically the scan resolution. What is basically the image resolution? Image resolution is basically the width into the height, right? It is given that it is the 100 pixels into the 200 pixels. So what will it give? Image resolution that we want to calculate. So physical width, how will you calculate physical width as it is given that it is 100 pixels, right? So what will be the, in terms of the height, how many inches will be there? Width, if I calculate, so it is 1000 pixels per inch. So in 1 inch, if it takes 1000 pixels, then how many will be in the 100 pixels? It is point. In the same way, height is given, it is 200. So it is 200 upon 1000, it is 0.2. When you have calculated basically the width in the inches, height in the inches, then we can easily calculate the physical size, that is basically the width into the height. And this way, it is a 0.1 inch multiplied by 0.2. Is it understood? So what is giving this idea? It is giving a fairly idea that a image which contains basically 20,000 pixels, that is of the size 0.1 inch multiplied by 0.2. Even see, one of the question was there in the morning that how this number of pixels. Yes, as soon as you increase the number of the pixels, the resolution that way increases. It is the same thing. That image resolution is there. It is 100 pixel. This is this one. More your better clarity, better fine details of the image will be available as soon as the number of the pixels will increase. Are you able to follow? Any question? Okay, is understood. That will be these numericals give very clear cut ideas how the things are actually working in reality. So we move ahead. Now the another question, what is the number of bits? See, where does the bit this play a role? See, when we actually transmit the data over a communication channel, then the data is transferred in form of the bits. What we are saying here, that what is the number of bits required to store 100 by 100 grayscale image. Remember, whenever this resolution is given 100 by 100, it is basically pixel only. Grayscale image with 256 gray level. What it is saying that its total, how many gray levels are there? It is 256. So how does it help? So how many bits are used to represent that gray level? Here, how do we calculate? It is log to 256. It is 8 bits. 8 bits per pixel, or we can say that the 8 bits are used to represent the pixel. Then we are what is given here, total number of pixels is given, right? This is basically 10,000 pixels. Since each pixel contains the 8 bits, then 10,000 pixel will contain the 80,000 bits. These bits basically you need, these number of bits are required. 80,000 bits. Some people say that the data is in the form of the byte. What is the relation? 1 byte equal to 8 bit. What we That's why we have divided this one 80,000 by 8 and it is 10,000 bytes and it is 9.77 KB. So now you are able to fairly see that when some internet speed is given, right? When some internet speed is given, what is the role, what is the relationship between that internet speed and the size of the image? So that has been shown here. Any question here? Or this is giving the fairly idea that because normally in our real life, yes. Okay, thank you. Now we come to the topic. In morning we discussed it and we had some questions. So that's why I decided that we can have some questions over this one. So in morning we took up the topic that whether our set is 4 adjacent, 8 adjacent and M adjacent. This, with this help of example, we are able to understand it easily. What is the question here that consider the two image subset, right? S1 and S2. This is S. Remember two image subsets. They are subsets only. This is means they are the part of the same image only. Here this is one, this dotted line is there. This is one part, this is another part, and they are in the neighborhood also. Now what we are saying for V equal to 1. V equal to 1. Determine whether these two subsets are 4 adjacent, 8 adjacent, or M adjacent. So what is V? V is basically the basis, right? So on that basis only, we can decide that whether it is fulfilling the adjacency or not. So remember, when I see this image, see for example, V equal to 1 is there. So means we are evaluating on this basis of one element. So here one, here what I am seeing 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0. Only at the boundary line, only 1, 1 is there. And here in the S2, only 1, 1 is there. Since we have to verify on the basis of that set, V set. Now we have to check out that whether it is a or whether it is diagonally connected or it is connected by the third way. When we are seeing it is the 8 adjacent, what we are saying that there is, as we are seeing it, it is diagonally connected. So what is this element? This pixel, remember, recalling again the things again, that here we are taking an example and what is this? This part is called pixel, right? This, we call it the pixel. We call it the pixel. What we are doing? We are basically checking that how the pixel P and Q are connected. So any answer that whether it is 4-bit, 8-bit or M-bit before going to the part. See if you see the problem here clearly. If you see that here it is basically diagonally connected only. Even so, one thing is clear that it is not the 4 adjacent. Now question is there whether it is 8 adjacent or M adjacent. If you understood that concept. Even now if you see it maybe we can consider only the M adjacent if there was a path from this one. From P, if this here, this marked 0, if it would be 1, then only there was a case that it would be the M adjacent. Because since there is no path, so only it is a one path is available and that's why it is considered as the 8 adjacent. Is it clear? The 4 remember, if you recall the 4 adjacent, it should be the direct one. For example, this one is there, right? This one is connected to, for example, 4 is very simple. Here, either it should be the on the horizontal line or on the vertical line. So this one and this one, they are neither in the horizontal line, neither in the vertical line. It is in the diagonal line. That's it. See, now only the possibility is there that whether it is a M adjacent or 8 adjacent. But remember, since there is no path here between this one if and this one, only there is only a diagonal path. So that's why it is a 8 adjacent. Coming to the next question, if you understood this one, we go to the next level. Consider the image segment shown. Now in set, it is V basically contains. So it contains 0, 1 and compute the length. Not only you have to set is there, but also you need to compute the length of the shortest path between P and Q. What is P and Q? P and Q is basically this one. P is basically this pixel. Q is this pixel. If a particular path doesn't exist between these points, explain why. Repeat for V equal to 1 to 2. So what we are saying, if we go to the first part, now taking to this V equal to, what is V here? 0 to 1. For whenever we will form the path, we need to check out with these values only. Because 3 values are there, 2 and 3 are there. There can't be a path if there are 2 and 3. So first we check out this value. So what are the, see, now we see this one. What is the path here? 1, 2, 0. Neighborhood path. Because only you have to consider 2 elements, 0, 1. We are going this one. First path. Then thereafter we can go to this path, second path. Then we go to this one, third path. And then we go to this fourth path. Right? And thereafter we need to now, but after 0, what we are seeing that you can't reach to the 1 without any diagonal path. It means the 4 path is not available. So since 4 path is not available, that's why you can't calculate the length of the shortest path. Now can you tell the length of the 8th path? 4 path doesn't exist, only 8 path, and we will check out the M path. First question, whether what will be the length of the 8th path? It is 3. One option, Vivek has given the answer 3. Five. See, 3, 5, we remove of that ambiguity. Remember, first path, second, third, fourth, this is the 5th one. So it is the 5 path. 5 path, if we go by this one, what if somebody says, no, here, now we go to the question again, right? Compute, but the length of the shortest path, right? 5 path is not wrong, but when the question is there that you need to find out the shortest, then what would happen? then I can go from 0 to 1 in this way. That has been shown here, right? 1 to 0, 0 to 1. But remember, if somebody asks me the shortest path, then I will go from 0 to 1 in this way, because diagonally it is allowed in the 8 connected path. That's why 1, 2, 3, 4. Is it understood? Okay. So now we go to the M path, right? Which is the another concept. M path here. So in M path, first we see this is till this part it is fine. 1, 2. But remember now when from 0 to 1, whether can we go through this path and whether can we go through this path. Remember in M path, as we discussed, that there is no ambiguity. There is only one way. What we are saying here, that diagonal path is only and only allowed if the alternate path is not available. So this diagonal is allowed in the M path, but this path is not allowed. Because in the neighbor, some element exists. That's why the earlier answer which we have discussed, that in the 8 connected path, or then it becomes basically the M path. In M path, because when we will follow it, remember, because here see, when you can go diagonally, but in the M path you can't go diagonally, because of the neighborhood condition, which what is shown, that the diagonal step used above 4, 2 to 3, 3 is not allowed, because one common 4 neighbor, 4, 3. See, what is this coordinate? Coordinate are 1, this one, see, this is coordinate 1, 2, 3, 1, 2, 3. Basically, the first value indicates that it is the which row, and second value indicates that it is the which column. So this indicates the path. What is this saying? P41. So what is this value? Which whose row is 4 and the column is 1. Second element whose row is basically 4 and column is 2. So this way we have basically defined the path. What is it saying? At this point 4, 1, basically your P pixel is there. And at this position, your Q pixel is there. So now when we are discussing this thing, one common 4 neighbor has value 1. So valid M path is this one, and all. And remember, please notice one thing, that final path is allowed because it's whatever both these neighbors, 1, 3, 1, 3 is this one, and 2, 4, they both have the value which is not common, which is not the part of the V. It means only, or in simpler word, we can say that the M path is available only and only when there is no ambiguity, when there is only one path available. So that's why it is a 5. Is it understood? It is a bit tricky. Can we proceed further? If it is okay. Now, can you calculate for the second path? We will for the V12. How will the things V12 will change? V12 will change. V12, it means we will check out the value that 1 and 2. That path is only possible when either of these values are available. So and we are checking basically for the four paths, shortest four paths. What we are able to see that this one is there, and after this one again we can go from this one. This path is there, and then after we can go, this path is there, and then after this path is there, and then this path is there, and then this path is there. So how many total steps are there? 1, 2, 3, 4, 5, 6. 6 steps are there, right? See, but my one question is there. Shortest 4, how is it 4? Alternative. You need to go through the, in 4 1 it is 4 paths, it is very simple to calculate. 3, 4, 5, 6. But somebody can say, no, I don't want to go this 2, I can want to go this 2. Yes, you can go. Again, you can calculate the path. What will the value? One path, the second path 2, third, this is fourth, this is fifth, and this is, again it is coming 6. That's why you can go either of the way. Now, what about the 8th path? 4 steps for 8 adjacent. Is there not any other shortest path? First we check out, first we try to understand in the given example, what is given. Then we will explore that problem further. So first point is this one, thereafter we are going to this one. And this is second path, this is 1, this is 2, this is 3, this is 4, and this is 5. Again we calculate 1, 2, 3, 4, and 5. Where is the issue? 1, 2, 3, 4. Here, so where is the issue? We see first, now we check out 4, 1 is there. This is the first one. Then this is 3, 2. This is fine. So here, remember, where is the catch? Because in diagonal element, I can directly go from 1 to 2 without taking the step. And this is one step, this is second step, this is third step, and this is fourth step. Is it understood? Somebody, so what has been shown here that you can't do it in 3 steps. Somebody say, I can directly go to this one 0 and then from 0 to 1. The only problem is there, if instead of 0 here, if it would be 2, then you can do it in the 3 step. But since 0 is not part of the V, that's why this path is not allowed. Now question is, what about the M path? M path is there. How many steps? Remember one basic fundamental that in M path there can't be a shorter path than the 8 adjacent. Because in 8 path diagonal is allowed at every stage. But in M path it is allowed only in some special cases. So can you tell whether the M path exists, and if M path exists, how many steps are there? Shortest path. Whether it will be the 6 only. Shruti is writing, it is the 6. Or will it be 5? It is 6. Ismail is saying no M path. See, M path, only difference between, see, first check out whether there will be M path. Shruti is saying, see, first we will check out. And when we are going from this path, see, remember we can go from this way. See, remember, M path is there. Even some diagonal element is there. So I only thing is that I need to avoid this diagonal element if alternate path available. See, now let's see. Check the same path. 8 paths under M adjacency. Remember, this path is not because they are common neighbor. So first remember, here you go first step, second step, third step, fourth step, fifth step, sixth step. Remember, see simple one trick. That whenever this diagonal path is there, it will be allowed only and only if alternate 8 path doesn't exist. But if alternate 8 paths, for example, in 2 paths are there, alternate, then it would take this common path. Are you able to understand what we are saying? Go to the last example. If you understand. Remember, here this path was allowed because that was the only path available. We are talking about basically the M path. If the alternate route exists with the 2, then you need to go through this path, right? 0 to 2 and this 2 to 1. But since there is no path through the 2, that's why we can directly go through, we can go through diagonal only when there is no alternate path. So here we will, since alternate paths are available, that's why we will not use the diagonal, and your M path will also be equal to the 4 path. Understood, I think. Further. Shruti, I think your point is clear. M path will always exist if there is a 4 path is there. It doesn't need to be it is the diagonal because it is both the thing. Now we come to the, I hope see it would be clear. We have done sufficient example. 4 and M are see not same. In some cases it is same, but it is not always the same. Whenever diagonal path is there, then because even it can, then the thing is different, right? Now see we come to the part, another question, which of following option is true? For example, P pixel is at that position, Q pixel is at that position. What it is saying that whether Q and P are part of the 4-point neighborhood, whether Q is part of the 8. See, what does this symbol show? It basically belongs to 4-point neighborhood of P. What it is saying, it is belongs to 8-point neighborhood of P. What it is saying that whether is it part 4 point, see 4 point it would be there, it should be here. इसका कहाँ? Here, either this one, this one, this one, this one, this one, this one. But here it is doesn't consist of it. Q is here, so it is neither part of it. What is this D? D is basically diagonal. Whether is it basically the diagonal, only diagonal neighbor? No, it is also not the diagonal neighbor only. Then it is not in all the listed neighborhoods of the B. I hope it clear. So what we are showing here, simple diagram. This is basically the image. Image is always a two-dimensional image with the locations of the different pixels. That question we will discuss later, convolution, etc. This is the much more advanced. Now the another thing. In morning also we discuss the distance concept, distance measure. So for example, compute the Euclidean distance D1, city block distance, and chessboard distance for points P and Q. Basically for pixels P and Q. Where P and Q are basically the What is there? This 1, 2, 3. Remember, 1, 2, 3 is basically their coordinates, right? Coordinate system. The actual value at the this 1, 2, 3 will be the pixel only, pixel intensity only. So this 1, 2, 3, this is 157. So how the different distance? When we compute the Euclidean distance, so it is basically 1 minus 1, 0. It is 2 minus 5, 3. It is 3 minus 7, 4 square, and it is 9 plus 16, it is 25, it is 5. What do you need with the city block? And city block, you basically take the mod of that difference. Mod of 0 plus mod of 3 plus mod of. What would be the value? 3 plus 4 equal to 7. Then we calculate the chessboard distance. What do we know the chessboard distance? Chessboard distance means basically in chessboard you compute basically the when we are calculating here, it is the maxima. So it is the maximum. Chessboard distance D3. Sixth question solution in the group. See, sixth one. See, sixth we will, yes, I will definitely will share, but when we will go through this content. Right now, after going through the content, then you will yourself solve it. What we are saying, see D1, D2, D3. So the maximum, so what is D3? Chessboard distance, it is a maximum value. Maximum value of X, Y, and Z. This is 4 here, so that's why D3 is. Is it understood? So this is 5, this is 7, and this is. Are you able to follow it? I think now you are able to appreciate the concept, distance measure. No problem, we can move to the next question. In image scan center, for example, we see the different type of images, for example, the CT scan, etc., MRI scan, etc. Center needs to store an image whose resolution is 1024 by 1024 with 8-bit gray level. What is given here? That your image is basically in given form of the gray level. It is not basically the colored image. A total of 100 layers are present. How much storage is required in GB? Because see, whenever you are taking the different images, what really matters that how much memory is available. That is the classical question that can you decide it? And thereafter the person asks, suppose this image is transferred via a medium having a transfer rate of 120k bits per second in the form of packet. The size of a packet is 100 bits and each packet is segmented. We will, whenever you through a communication, you send basically the packet. Each packet is segmented by a start flag. Remember, it is fine that you are sending the packet, but at the receiver end also you need to be very clear that how in the same sequence I need to receive the packet. So when you send continuously, so the bits may accumulate and it get mixed. It leads to the distortion of the actual data. What do the people do? People follow a strategy. They use the start flag and the stop flag, which contains some special type of bits. What we are saying that each packet is segmented by a start flag and a stop flag of 14 bits. Now what you have to do, compute the time required to transfer the image. That is the problem. So for example, you have gone, some person has gone for any CT scan center or MRI scan center, then he or she is asking that when they have given the data, how much time will it be required, minimum time will be required to transfer their data. That is a simple problem. So how much storage is required? So whenever it is there, so in remember earlier also problem, if you remember, we calculate basically the bits in form of the KB, right? KB. What is required in GB? So it is basically pixels. So what is the basic unit whenever we are saying that the image resolution is given basically pixels by pixel. Pixels basically per layer, it is 1024 by 1024, or we can say basically it is the 10 raised to the power so 24. It is 2 raised to the power 10, 2 raised to the power 10, and then it is this one, 2 raised to the power 20. The number of bits per layer, if you see here, so how many bits? So these are basically pixels. What is given here that each pixel with a 8-bit gray level. Remember, each pixel is basically represented by the 8 bits. What do you know the 8 bits? 8 bits we can say it is basically the 256 gray level. Why? Because 2 raised to the power 8 is basically 256. Right? Why 256? Because it is from the 0 to 255. That's why it is 256. So when 8 bits are there, so what we want to do, we want to calculate the total number of bits, and total number of bits is basically multiplied by 8 into these many bits. Remember total number of layers in a one image are basically 100 layers. So this is the thing at the basically one layer, and this is the picture at the 100 layer. Now can somebody calculate in the GB? What will be the next step if you understood? I hope see the things will be clear to everyone. If not clear, see, please acknowledge. So, if it is clear, then please tell that how much storage is required in GB. In GB, basically, can you tell how many bits are there? GB, it is giga. How many bits are in the giga? Mega is there, 10 to the power 6. Then giga is there. You can see here, see, 1 byte basically is 1 GB. See, what we can see do? Now we are clear about the bit. Only we need to be there about the things we need to convert it into the byte. What we will do here, that 1 byte, it is basically 8 bits, and 1 gigabyte, remember, when this is capital B, it is basically the byte. This capital byte is basically 1024 to the 3. These many number of bytes. So how much is there? It is almost 10 to the power 9. If you recall, 10 to the power 9 bytes. So first we need to convert these our bits. Earlier we had the calculation in the bits. First we calculate into the bytes. These number of bytes are there. When these number of bytes is there, then it is will be divided by our this 1024. When it will defend it will be that much data is there. So can you imagine? See, for example, even when we talk about the movie, etc., also how much time will it require to be transferred? Because see, whenever we are sending the things through our WhatsApp or anything, what really matters, it is the size. So here, see, this much, it is almost it is 0.1 GB. It is fairly a good size. This is storage required at this. Is it clear? Any question? This way, the basic image, whenever we take an image, it contains the resolution. Resolution contains the information regarding the pixel. And with the help of the pixels, how we are able to calculate the size. That thing is shown in this example. Can we move to the B part, or if there is no question? I hope everyone is able to follow. Because now there is a reduction in the response. Because once we are able, see, any one basic thing to learn any subject, try to correlate with what is happening in the reality around you. Once you are able to connect it, the subject, you will automatically begin to learn. Most of the students, see, most of the people, when we tease the subject, etc., it is or even interesting also. Yes, it is basically 10. It is exactly thing, but if you recall, 1 GB is basically 10 raised to the power 9 byte. It is 1000 this one. So if it is understood by everyone, so no doubt is there. We move to the next part. That what is the time required to transfer the image? Remember, whenever we see that the time required to transfer the image, it is basically given by its transfer rate. How much transfer rate is there? Yes, that you calculated it. So when we are saying, see, transfer rate is this one, so this much GB is there, so packet. But remember, when you are transferring, one thing also you need to take care. What it is saying, 1.94. Want to say anything? 'Not understood clearly. 1.94 in what sense you are saying? One point, also hour you are telling it. See, let's check. Okay. See, let's check here. See, for example, key thing is there. Remember, only thing when you are basically transferring, you need to remember one thing, that it is basically sent in the form of the packets, and packet where start bit is there and the stop bit is, start flag is there and the stop flag is there. So what we are saying, that when this start flag and stop flag, this will also continue. Your packet size, you go to the question again, see the size of packet is this one. And then when you are saying start flag and the stop flag 1414 each, so your total bits per packet will be 128 bits. When you are saying basically 128 bits, so this is one packet. What is in the question? Size of packet is 100 bits. Each packet segmented by itna. Suppose computer time required to transfer total image. So how many total packets? Right? How many total packets you need to send? So how many packets will be there? Total in this image, so that you need to see. Total data bits to send. See when it is this one. Total bits it is there 128 bits. Total data bits to send. So total number of packets. So what we are saying, the total your size of the image is this one, right? Total 100 layer. So how many packets will be there? Packets will be this one. What will packet decide? Packet will decide that the number of bits. The total number of bits per packet required is basically 128. After calculating the packet, you will calculate how many bits you need to transfer. So now you are able to calculate the total number of bits. Now the thing is pretty clear that if 120 kilobits per second are transferred in 1 second, then how much time will be required to transfer these number of bits? So it will be basically 8947 second. It's better. We can calculate an hour, etc. So this is basically 2. It's basically almost like 2.49 hours. So what we are saying, when you will calculate, it is zero point 0.5 hour multiply by 60 minutes. So it will be almost 29 minutes. So it is a 2.5 hour you need to wait. Whether your if house is nearby, if you can reach earlier, then don't wait to transfer it. Or if it is far, if you are in the distant city, then you can decide. Is this understood? These are interesting test cases. So this is not basically 1.94, it is 2.49, I think. Normal straight. So that's why see, what do the people use? We will see later they use the compression etc. Any question? So you are there is a question, we can move further. Now we take another problem. Given a grayscale image on paper whose physical dimension is 2.5 inch by 2 inch, scanned at the rate of 150. What is this scan resolution? What is the DPI? That is basically dots per inch. Calculate the following. How many bits are required to represent the image? And how much time is required to transfer is given at this point? 28 kilo bits per second. Can you answer? So we take a break also at this point, 5 minute break, and you try to solve this problem if you don't feel to take break. So it contains both the things. Why are we calculating the number of bits required to represent the image? Because that only will decide the time required to transfer them. These are all the actual real cases in here. Any question before taking the break if you have? Are you all with me? Are you able to follow? Yeah. In afternoon session, we have put exclusively the problem solving session so that see we don't feel sleepy, we don't feel drowsy. I hope see everyone is with me in the awake state. So let me take a small break and then we will come back after 5 minutes. We can continue with this part. If you have any questions, you please type in the chat box so that we can address it, even if you find it anything. The main So welcome back. When this is another problem, what we say here, that given a grayscale image there on paper, as we seeing that there is dimension. What is this given? Basically 2.5 inches given, that is basically the width is given, the height is given. This is basically scanned at the rate of itna, calculate the following, how many bits are required to represent the image. So it is like the first problem that we initially discussed it. So what has been shown here, that physical dimension, it has been shown here that it is basically the 2 inch, this is basically the height, this is basically the width. So scan rate, this is basically the given this one. So when width is given, so this much inch is given. 1 inch contain 150 pixels. So this much height contains how many pixels? It is 2.5 into 150. So this one. Main thing is that how many bits are required. So what we will need to do, again see, first we will find out the number of the total number of pixels. Then we will convert into a bits. That will be the same thing. So width is basically given here 2.5 into this one. This is 375 pixel. Height is given. There is 300 or 300 pixel. So total number of pixel is given this one. So this is divided. So this is each pixel basically again is of the 256 level. 250 is the grayscale level. So since contains the 8 bits, that's since 256 level, so that can be represented by the 8 bit. That's why this is multiplied by 8 and this by this many bits are given. So what is asked in the question? How many bits are required to represent the image? That is this. What is time is required? So time is required. The speed is there, that is 20 kbps, and how many these bits required? So that will be given that the total number of bits divided by this kb kilobits, so this is 28,000. So that is given. So it is, will be transferred into a 32 second. Another type of the question, when for example, when you are saying, suppose you have an image that is 20 row, right? And as an aspect ratio. What do you mean by the aspect ratio? Aspect ratio is basically the width upon the height. When you will see the numerical, see these are the different ways to provide the information to find the total number of pixels in the image. So total number of rows are given here, that is 20, and aspect ratio is given. If aspect ratio is given, so you will also easily able to calculate the width. How you calculate the width upon height is this one. So how number of rows? See the first row, then second row, third row, fourth row. So these number of rows basically decide the height, right? But important thing you notice here that this is not from the almost 20 unit, right? Unit is given and width is basically what 20 divided by 2, it is 50 unit. So total number of pixels, what it has been showing, that an total number of pixel in the image. So rows into column, it is given. So here when you will multiply that, the total number of pixel is 20, columns is 50, and that is this. Another related problem. If you want to resize this one image to a one that is 600 pixel wide with the same aspect ratio as the original image, what should be the height of the resize image? The ninth one solution, which one? Ninth one, we have already discussed it, right? Any question? Yeah. See, actually, the purpose of this problem is that so how these things are actually connected with the actual thing in the actual related life, how this data is there, time, size required, because hardly you will see anywhere the pixel is involved. But if you go to the resolution of the image, then you will see that data. I hope it is a bit clear question. So that's why we quickly taken to the this one. That is, I think 10 would be clear. Going to the 11 one. What you're saying, if we want to resize the image or what? This is basically given basically the width and this is basically the height. Image to a one that is 600 pixel. 600 pixel wide. Now it want to basically reduce it. Reduce it to what will happen? Then the height will actually increase up. The same aspect ratio. No, he's saying that the same aspect ratio. Aspect ratio means basically width upon height is given. So height will also be decreased. What should be the height of the resized image? It has been shown here. Aspect ratio is there. Aspect ratio. This is this one. So it is when you calculated height. So it is actually it is height into the width. It is showing this one. Width is given. Remember, see, whenever you are solving this problem, so one thing should be here the mention is that here it is height into width. Otherwise, it is taken width. So this problem is given that it is height into the width. It need to be very clear. Otherwise, by default, see what do we take? Basically, width into the height. So this is shown here that it is 768, 124, and then resized image, and it has been decreased to the 600. So the height will also be increased. That is the 800. Now we took another question that the, for example, grayscale image consists of 256 pixels, and each pixel is represented using 8 bits. Why we are using the 8 bits? Because we are using basically the 256 level. 0 to 255. 0 basically for the black one, 255 for the white one. If the transmission occurs at a baud rate of 2400 baud and each symbol equals 1 bit, determine the time required to transmit the image completely. You are seeing it, same type of problems are asked. So what has been there? Grayscale image. So this is clear, 256 pixel. Each pixel is 8 bits. So it is not difficult to find out the total number of bits. That is simple. It has been shown here that is almost around the 2000 bits. So time required basically 2048 bits upon bits rate. What is this baud? This basically bits per second. When it is the per second, so it is basically the less than 1 second. It is basically able to transmit 2400 bits in a second, and 2048 it will require less than a second. It is 0.853, or we can say it is 853 milliseconds. Is it understood? Are you with me? Or should we take up the conceptual part? Feel it that it is understood. We can come to the conceptual part quickly. But you need to assure that you are with, we all are together on the same boat. Please respond if you are here. If you not respond, then definitely your image is only here. Okay, thank you. So we are not just this question. No problem. You don't need to worry about the question. Main concept is there. Right. Yes, thank you. People are here, some people are here. So we take up the one more problem. We take up this last problem, then thereafter we will consider the other concept. So what is this problem? Yes, family. Samli, I will definitely share these slides. These are for you only, you people, that you can go through this content. And but the only thing is that while once you are able to understand, even if you are able to listen the things, if you are able to have some catch, then you find it very easy to understand the material after seeing it. What is saying? Consider the following the two images. So this is basically the images there of the 3x3 size. What are these values against the what? Can somebody tell me what are these values consist of? F1 and F2. This box contains 200, 150. Intensity is very good. These are basically the intensities they come between the 0 to 255. So what has been asked that perform the addition, perform the subtraction, multiplication, division operation. Assume both the images are of the 8-bit integer type. 8-bit basically again indicates that it has a maximum 255 value is possible. So how will you perform the addition? Addition, see, for example, you are taking this image 137. See, even when you see the thing that we alter the images, people do the different type of operation on images by adding the image, etc. So how do they do it? Again, by these type of some operations. So here we will see what happens when you apply these operations. For example, F1 is there, F1 is this image is there, F2 is there. If you will add up both the things, so what will happen? You will get the value 51, 150, 132, 50, 70, 230, 400, 100, 225. See, what will happen to this 400 value? Because see this value, the maximum value of intensity is by the 8 bits, maximum value can be 255 only. So it will be represented by 255 on this. What about the subtraction? When you do the subtraction, so in subtraction, basically when you are subtracting I0 and then 0 and Fi, the absolute. This is our right. Nishida. So when you are subtracting it, so you will get this value minus minus value, all value are less than 0. Because see, we do not have that scale. Are you able to understand? See, because we do not have that scale which can capture that much intensity. So what we will do, we will approximate. It means that 400 value is such up to a high level that it can be approximated to nearby value, and nearby value is 255. In the same way at subtraction level, that minus is these minus value are nearest to the 0. So again we are approximating it. Please be one clear that here we are losing the information. When we are doing these operations, definitely we are going to miss the information, lot of information. But because our resolution if fake it is, so we'll get that data only. So again, see here as it has been discussed that the minus value, it will be marked by 0 and only 75 will remain. Then another case it is multiplication. Multiplication is the same thing. So what I have been showing that when you are multiplying it here F1 into F2, so multiply it. So wherever the value is greater than 255, it will be 255, and where it is, so this will be 255. In division, see what has been shown, it is basically 0.02. Again, see it is most closer to 0 value, that's why it is 0. And it has been mentioned this. Perform the logical AND OR and difference operation. What is in this case? So in this case, see again AND NOR operations. Today we when you use a different type of gates etc. we use these operations. So 0 1 value is there instead of other value. How will we do the thing? So first of all, AND means basically you multiply it, OR means basically you add up, not means basically the inverted sign and difference operation. The equation here, F1 is there and F2 is there. F1, when we will do it basically and a thing, so when only one is there, it will be multiplied at other value, it will be 0. So it has been shown here. So F1 and F2 is this one. F1 or F2 is this one. All the value will be add up. So it will be add up 1 0 1 1 1 0 1 1 0 1 and it will be add up 1. Not F1. Not F1 means again you will take the inverse and instead of 1 1 it will be 0 0 all the 0 and instead of 0 it will be 1. So F1 F2 is there when you are taking basically the F1 minus F2 somebody asks you, so you can also do it quickly. So F1 minus F2 1 minus 1 basically uh, what do you mean by this thing? It means basically F minus F2 that and not F. And not F2 means basically you have taken the F value and then you have taken the not F2 value. Not F2 value, then you have to multiply it. When you will multiply this thing, so you will get all these. So another problem is consider the following image, find the 4 adjacent and the M adjacent of pixel 1 1. Where is the pixel 1 1? Is the 4 pixel 1 1 and remember it is always defined in context of the capital B. B capital basically the allowed value. So can you find out the 4 adjacent and M adjacent of pixel? So it has been shown here that it is coordinates are mentioned 0 1 2. It is 0 1 2. So what are the what is showing here? Pixel P 1 1. What is basically the 1 1? 1 1 is basically the this one. This is the 1 1 is basically the this because here we are starting the things from the 0, right? Unlike we have started earlier from the 1. So what will be the value here? 1 it is there, 1 it is there, and 3 and it is P here. So what are the neighborhoods in the 4 adjacent? This one is there, D, B, E is there. G, why G is not there? Can you tell? G is not in the neighbor. So what is the reason for it? Yes, value 5. But here, will it be the part of the 4 adjacent pixel? Not in V, absolute. Main deciding factor is this character. It's not in the part, that's why it is there. Now we are coming to the basically part, the M adjacent pixel. What is the M adjacent? So what is the problem here that you have to find out the M adjacent of pixel P 1 by 1. So here that it is basically what has been shown. It is P and they are not M adjacent. It is now see again you need to you will see here A it is not adjacent. Only see these values again, but which one of them are the M adjacent? When we will check it, so N4, so what do we calculate? N4P is this one, N4A is this one. When we take the common set of P and A, we should get the null. If it is not the null, then it is not the M adjacent. In the same way, we see the edge. Again, we will take the neighborhood of H, 4-point neighborhood. We take the 4-point neighborhood of P, and then we check out if there is not any common point. So if there is no any common point, then only you can say it is basically the M adjacent. That's why neither A, C, H, neither of M is there. Now we come to the this is some more problems are there. I think you will be able to we quickly go through it. Consider the image augmentation shown in this one. Compute the length of the shortest 4 path, 8 path, and M path between the pixels P and Q. It is shown here. Even we have done the similar problem. Only I think neighbors have been changed. Little bit changes there, so that way you can able to calculate. This is the same problem, so this is another one that even we have calculated. Other problems are same in nature, and two little bit problems is there. So for example, how many cameras are required to find a 3D point using the image coordinates of cameras? So to determine a 3D point from a 2D image, you need triangulation. What do you mean by this thing? A single camera projects a 3D point onto its 2D image. Depth information loss, so you can't recover the 3D coordinates. With two cameras, you get two lines of sight whose intersection gives the 3D points. This is a bit clear that it is only with the help of the two cameras that you are able to get it. For example, you need to calculate the uh, image. So what do you mean by the negative of the image? See, it is basically that 0 is there. So it is the highest value. It is 255 minus this value. That we will do, and minus, so you will calculate this one. So negative means, for example, something is looking as a white, it will seen as a black. Something is written as a black, it will seen as a white. That's why it's called by the negative. The important thing here that how you are carrying out this operation. By this simple subtraction, we are able to get the negative of the image. Given here, so this is 0, this is 255 minus 0, it is 255 minus 50. 255 minus 100. So this way we are able to get the negative of the image. So again, it is another problem. If you consider the following 5 by 5 grayscale image, perform a digital negative transformation of the above image. What you need to it is, but remember the important thing here that when you are taking this image, so what is basically the highest value, right? So when we are taking this image, gray by grayscale image, so what they are saying. They are saying that the image contains values from 0 to 7. So L equal to 8 is there. So whatever the highest value is there, 8 minus 1 minus R. So when you calculate this one, so calculate the S. It is exactly the same as. If you recall, see, S equal to T function of R. But here the operation is negative. So this way we will able to calculate the image, and we will calculate the equal to image. Original image is this one, and negative images. Another example is here given 5 by 5 image. You perform a digital negative transformation of the given image. So any ideas of what you will need to do if you understood the earlier example? Yes, yes, definitely. So Janne, we will share it. See, some question was here, why G is not 4 at this end? I missed this question. Not in we. Anyway, see, we will just revisit it first. Coming to this question. Negative transformation, can you calculate it? Again, see, it's a simple thing. Yes, L minus 1 minus R. What will be the capital L here? R is basically the intensity, present intensity. Yes, it is level, or basically it is the value. It is the overall value. Yes, 255. When you will see this part, so again, see it is there. It is 255 minus R, and it has been shown here. This is you will able to calculate all the values, and you are able to calculate this is the original image and this negative image is there. We will see in the lectures also that how does this negative transformation helps in the better recovering of the image. Find the image negative of a 5-bit grayscale input image of size 5 by 5. Here the thing is that see what should be the maximum value, what should be the capital L. Image size is basically 5 by 5 bit, depth is basically 5 bit, gray levels are this. As it has been shown here, yes, it is 5 bit. Remember how many bits are required? How many bits are required? So in case of the 255, when we are taking it is basically 2 raised to the power 8, and in case of 5, it is 32 values maximum. Actually, see another way you also see that what is happening here, that the in negative, see what happens. Negative means the lower value becomes the higher and higher value becomes the low. That has been shown here, maximum gray level transformation that has been shown. Consider the following 4 by 4 grayscale images there. Perform thresholding with threshold value capital T equal to. So what is to be done here? See, we have performed the thresholding. Threshold value capital T equal to 4. That the maximum value can be over here. So important thing here, that's the L equal to 8. Why L equal to 8? Because the nearest bit, see, you always need to take the number of bits required. The number of bits, see, it is the 2, 4 is less than the 6 value, 7 is less than 6 value. So that the higher number is 8 basically, 2 raised to the power 3. That's why we are taking basically 8, 8 minus 7, and then 7 you have calculated it. This is what we have done here. This is 7 minus 4 that we have done it. What will be the value? But see, one condition is given that perform thresholding with threshold value T equal to. It means if wherever the value is basically 4 threshold value, then it should give. See, for example, so what it is saying that when R is basically equal to greater than 4, then L equal to 7, threshold means either it is 0. What it is saying, if R equal to how this function is translated into normal level, that equal to 0, 1, 2, 3, that S will be 0, and when it will be equal to 4, 5, 6, 7, it is S equal to 7. So only 2 values are there of this thing. But this is only solution when we are saying thresholding with threshold value capital T equal to. Another problem is there, perform clipping given the 4 by 4 grayscale image is there. So total 16 pixels are there. You need to perform the clipping. Clipping means basically you are using R1 equal to 2 and R2 equal to 5. So when thresholding is given, there is no need for negative. See, yes, thresholding is basically not like the negative conversion. It is basically the transformation. If you really see these operations, or we are saying basically this is the transformation. In another problem, it is given that perform thresholding with threshold value equal to 163. What do you mean by this one? Again, see, it is a thresholding means basically it is forming the boundary. There's a boundary between the one line that if the values are here, this threshold, then they are maximum, otherwise they are minimum. So it is there. So for example, here it is there, or if it is equal to the 163, or it is more than 163, which is case of the 241, 243, this one, so it has become 255. At other value, it is 0. I hope it would be clear to you. This is another way to perform the operation on the image. Can we proceed further? I think I am not a bit faster, but since they are numerical, so I'm quickly going through it. So when thresholding is given, there is no negative. Fine. So this is intensity level slice. So remember, here we are saying two values are there. Remember now, earlier TR was basically only the one-dimensional function. Now it's basically a two-dimensional function. R1 is there and R2 is there. What it is saying, it is clipping without background. It is there clipping with background. What it is saying, see, this is for this value is given, see 4352, this is given. So it is saying that it is slicing. That if it is between this value 3 to 5, then it gives 7, otherwise it is 0. So even 3 and 5 are included. So even 3 and 5 are included. 3, 4, for 3, 4, 5 value, it is 7, and otherwise it is 0. For 6 also it is 6 also it is 0, and 2 that is 0. In this way we are done this. So what is this image? This is basically a without background. It has been shown. So what would happen when there is a in the background? In background means that some value is there. So what do you mean by some value? That it is 0 here. It is 0 here, the value will remain. So add the other value, then where it was 0, so we will mention it as the R. What we have done it, when you will plot it here between R2S. Somebody raised a question in the morning that what is the relationship, whether it is a multiplication. No, it's basically a transformation. What type of transformation it is there? That when R is there, it has been scaled here in this way. So how it has been scaled? It has been scaled that between 3 to 5. 3 to 5, we are basically reaching the maximum value, and at other value, it is basically the same, is the almost the same value. But this is the background. Another problem, perform the gray slicing R1 equal to 3 and R2 equal to 5. So what we are going to do here, it shouldn't be difficult for you that between, again, see the question is there whether it is with the background or with the without background. If it is with the background, then definitely the other values will remain there. If it is not background, then the value will be 0. That has been shown here. So gray level slicing, that has been shown here 0. So when nothing is given, so we take it without background, and then we are taking it calculate this value. So this is logarithmic transformation. So that we will see. Now we will at question 30, we will go to our content part, theory part. Are you with me? I think I'm not a bit fast because these are the numerical similar in nature, and they generally give the idea. That's why we have quickly gone through it. But see, it's very important in engineering. See, usually we understand that numerical is simply some mathematical problem. See, It is not simply a mathematical problem, but it gives you the idea, see that how the different things are actually working in reality together. This concept will be very useful. So if you don't have any question, we move to the our theory part or our fundamentals part. How many have really taken the scanned copy of your image and you have converted it into the pixel to gray level, etc. You take your own image, your colored image, you scan it, and after scanning the APG form, you can convert it into this one, into the digital form, the MATLAB form, and then you apply the different operation. MATLAB or Python, both the things it can be done. Then you will really enjoy these operations, that how you can even see when you use your mobile and different filters are there. While when you scan the image, see, it gives you the original, it gives you the option. For example, when I'm using this mobile, for example, when I'm taking the image, so see what is happening here. It is giving the option that you want the original color, light and color, gray mode color, magic color, so etc. These different type of things are there. So how they are doing it? They are bringing the image to basically a digital level. At the digital level, then they are applying the different operations, and then these things are happening. Any any question, suggestion, please feel free to share. So see, so it is the last 5 minutes. So what we will. So tomorrow, see, we will have an expert from the IIT Indore in the morning. See, he will definitely see more. See, what I will suggest you that whenever you are doing, see, we have also the option basically of using basically the MATLAB, etc., MATLAB Python. But the only problem is that the problem we face that since it's the communicate through the chat box actually, then it becomes difficult. Otherwise, some later session, I'm thinking that actually the programming based sessions are more better in the lively session. When we are doing it because somebody stuck it in the coding part, it is very difficult to resolve it. So you can't share the screen, you can't see it. That's why I decided that we take up the numerical. So next part of this course, we will see that whether can we organize at some real-time level. Apart from it, see tomorrow morning lecture will be actually the continuous full lecture. Full lecture because see where all the aspects of image processing will be discussed. Right? He is the Professor Dr. Vivekanand. He will discuss the things in the totality. So you please don't be panic when he is discussing the different concepts because see, I can't ask the expert to discuss some aspect only. But in the totality, when you will see, so whatever the gray areas are there. So they will actually be the guiding factor for us, that what thing we need to cover. For example, one guiding factor was the one slide today in the morning, that where we have the sequential part of the image processing, where we covered it. Tomorrow also we will see that how do the people, they see the things in the totality. Then we will again see, it will my lecture. We will go through the thing from the basics, because once you will have the basics, you enjoy the thing. Then applying the thing, you have the confidence, build up your confidence, and then you automatically want to take the new thing. That's why I have kept that complete portion. I have left that complete portion to our experts part. I have not restricted them that you need to take that specific content. They will take it. But you don't worry, whatever your questions are there in your slide, we will address it. Just to note down it if you are. So we will, in the afternoon session, we will see the application of these concepts, of which concept of this slicing, etc. How this slicing, how this negative transformation of the image actually helps in the reality. That we will see at the fundamental level. So that's all from our side. I want to thank my student Anand and Suman for their presentation, for their really a major cooperation, where Suman has basically prepared the slides, and Anand has basically assisted in conducting these sessions. You are WhatsApp level, and you are at whatever he is answering from. Without Anand, it couldn't be possible, and slides part couldn't be possible without Suman. So in the valedictory session, we will meet. I will show you my team with whom I am working. So it is our team's work only that we are showing. So we can conclude, provide. But first, if you have any question, anything is in your mind, not question, suggestion, please feel free. Remember, yes, definitely these slides will be shared. I slides, recording, everything will be shared for you. But see, what is my experience, that see, you are able to use the slides. Yes, it will be uploaded to Canva. Absolutely. They will be uploaded. Content wise, but you need to go through it very quickly within 2-3 days. Then only you will be able to absorb the thing. Otherwise, then it becomes content. Yes. Any suggestion of anything, what is in your mind regarding the image processing? What do you want to learn? What do you want to? Because fortunately, I'm the coordinator of it, so I have the flexibility to design the thing. But but it should be grasped by all. And remember, take my words, the image processing is such a relevant field that today, if you begin to work anything upon it, it is not only interesting, it gives you many results in form of the research. Because it is so lively actually. Definitely, if you want to publish the research at the general level, it may take time. But it is so interesting that once you go into it, once you go into the depth of any part, not the full image processing. Take my words, if you take into any segment of it and you have really internalized it, you are going to publish a research paper. You are going to be in research papers which is required for our PhD, for our research growth, that will automatically come out in this field without going into the full detail of it. You take any part, any segment of the image process. That is the most beautiful part, unlike the other subject where you need to cover all the things in the totality. Thank you. There tomorrow. Yes, research medical images also. We will have the yes. Medical image, see many things are going on because one decision can change the whole analysis of the doctor. Tomorrow we will again come at 11 to 1 first session, then 3 to 5. Sessions are designed in such a way so that you can have the sufficient time for lunch as well as your job things, etc. And not very compact one, not very pressurized one. Thank you. Yes, sir. Deep learning, etc. We will do it. We will cover in the last all these things. Thank you, Bharti, Hemam Begai, Saujan. Right, very happy to see your response, your continuous interaction. Dr. Nitin Padaria. Padaria. Thank you. So we are doing Shashan. Living.